Coming to the chapter 2, which is 2.1 is network theorems, AC circuits. So theorems we have already done. Now I'll straight away start with the first problem on superposition theorem. Question number 1, it says using superposition theorem, find I naught. The diagram given is, now here you'll have AC sources at an angle 5 at an angle 0, J10 minus J2, then 4 ohms plus minus 10 at an angle 90 degree volts, 8 ohms minus J2 ohms. I naught is flowing here. So using superposition theorem we need to find the value of I naught. You have two sources, 5 at an angle 0 and 10 at an angle 90. So first I'll consider 10 at an angle 90 degree voltage source. So 5 at an angle 0 degree amperes will be open circuited. So the modified diagram will be minus J2 ohms, 4 plus minus 10 at an angle 90 minus J2 ohms, and this is 8 ohms, this is J10 ohms, and here we'll have now IO dash. We need to find IO dash. So these two are in series, so it can be replaced with a single impedance, say Z. So I'll modify the diagram, and instead of a resistance in series with inductor, I'll replace with a Z, and the value will be 8 plus J10. This is minus J2 minus J2, 4 as it is, and the voltage source. This is 10 at an angle 90, IO dash, and 4 ohms. Now we need to find IO dash. Again we can have these two impedance and the capacitance in parallel. So I can find a total, say Z1, which will be minus J2 into 8 plus J10 and minus J2 plus 8 plus J10. On simplification you will get it as 0.25 minus J 2.25 ohms. So that is Z1, the equivalent of this entire part. So I can draw the again the modified equivalent circuit. This will have minus J2, and here I'll have only Z1, 4 ohms, and the voltage source plus minus 10 at an angle 90 and IO dash. So now I can find IO dash very easily, total voltage upon total resistance. So this is nothing but this is equivalent to J10. So J10 upon total impedance is 0.25 minus J 2.25 plus 4 minus 2J, or I can say 4 minus 2j plus z1, which we have found out. So after substituting, you should get it as j10 upon 4.25 minus j 4.25. So your IO dash will become in that case as minus 1.17 plus j 1.176 amperes. So this is the value of IO dash, that is considering 10 at an angle 90. Now we'll do with the other current source and shorting 10 at an angle 90, and then we find IO double dash. Now considering 5 ampere current source, that is 10 at an angle 90 degree, will be short circuited. So we are considering now only the 5 ampere current source. So the modified diagram will be 5 ampere J10 minus J2 4 ohms 8 ohms minus J2, and this will be shorted. And now IO double dash will flow in this direction. Now we can do by the mesh analysis. So I am assuming I1 flowing here, I2 in this mesh, and I3 in this mesh. From figure I can say I3 is straight away 5 ampere. Then I'll apply KVL to mesh 1. It will give me uh, 8 plus J8, 8 plus J10, or say 10 minus 2 is 8. Total impedance in the first mesh I1 minus common with the third, or first you can start with the second, so plus J2 I2 common with the third is minus J10. So with whatever is common we put it minus, but since it is minus we are writing it as plus. The impedance which is common between the meshes we usually write with minus. That is the shortcut method you can use. I3 equals to 0, equation number 1. Then KVL to mesh 2 will give me 4 minus J4 I2, that is total impedance in the second mesh. Common with the first is plus J2 into I1 plus J2 into I3 equals to 0. So the equation you can write it as J2 into I1 plus 4 minus J4 into I2 plus J2 into I3 is equal to 0. Call this as equation number 2, and I am calling this as equation number 3. So from 2 and 3, if I substitute 3 in 2, I'll get, from 2 and 3 I'll get J2 into I1 plus 4 minus J4 into I2 plus, when I substitute I3 as 5 over here, I'll get J10 is equal to 0. Now I can write I1 in terms of I2. So writing I1 in terms of I2, that is rearranging this equation, you will get I1 as 2 plus J2 I2 minus 5. I am calling this as equation number 4. Now substituting 3 and 4 in equation 1 will give me the value of I1. It will give me the value of I2 because I am removing I1 and substituting I1 in terms of I2. So when I substitute 4 and 3 in 1, it will give me the value of I2. So substituting 3 and 4 in 1 will give me 8 plus J8, 2 plus J2 into I2 minus 5 minus J50 plus J2 into I2 equals to 0. So I'll get I2 as 90 minus J40 upon 34. So this will be 2.647 minus J 1.176. So IO double dash is nothing but minus I2. So this will be minus 2.647 plus J 1.176. Now by superposition principle, IO will be IO dash plus IO double dash. So that comes to, therefore by superposition theorem, I'll write IO as IO dash plus IO double dash. So that will come to minus 3.82 plus 2.352J. So that comes, if you are writing in the polar form, 4.486 at angle 148.37 degrees ampere. So this is how we have found the value of current using superposition theorem. Now one problem you can try on the superposition theorem. The question is, find current I naught in the circuit using superposition theorem. The diagram given is, need to find the current I naught using the superposition theorem. Thank you.